This video will cover the Year 10 Fundamentals, Indices and Interest test preview. These are the sorts of questions you should expect to see at a C level. I'll put some time tags in the description below so you can skip to question numbers or types. For this topic, we're going to need to be familiar with the index laws and comfy using them. So there are 6 rules that are generally used. They're not in any particular order here, although I have put that first one there because it tends to be a nice easy one to work with. And if I've got a hard question, I tend to manipulate it to try and make it into a question that can be answered using this law. So let's look at that one first. If you're multiplying numbers that have got indices and the base number is the same, and it's very important that the base number is the same, what you can do is you can just add the indices together. So if we've got 2 cubed multiplied by 2 squared, then we'd end up with 2 to the power of 5. And if you'd like to see how that actually works, 2 cubed is 2 times 2 times 2, and 2 squared is 2 times itself. So here we've got 2 cubed times 2 squared, and there's 5 2's being multiplied by one another there, so really we've got 2 to the 5. In the second example, or in the second law, is when we're dividing. Now it's important again that the base numbers are the same, but if they are, we can just subtract the indices. So if we took 5 to the 5 divided by 5 to the power of 3, we would end up with 5 to the power of 2. And again, if you'd like to see how this works, we could take 5 times 5 times 5 times 5 times 5, so 5 to the power of 5, divide it by 5 times 5 times 5, so 5 to the power of 3, and we would see that 3 of those 5's are just going to cancel one another, and we'd be simplified to 5 squared, or 25. And the third example is when we've got brackets or parentheses, and in this case what we do is we multiply the indices. So if we had something like 3 to the power of 3, and that was squared, then we would end up with 3 to the power of 6. And a good example of this might be, well, if we want to have a look at it another way, we might have a look at it as 3 cubed. And if 3 cubed is multiplied by itself, then we'd be multiplying it by 3 cubed again. We've got 6, number 3 is being multiplied by one another there, so we've got 3 to the power of 6. So it's nice and clear to see how that's working. In the fourth example, we've got negative indices. A really common one is 2 to the power of minus 1. And this is just another way of writing a half. It's the inverse rule. And so here, if we take another example, because I think it's probably a good thing to name up here, if we take 3 to the power of minus 2, the answer to this one is 1 over 3 squared, or 1 over 9 if we simplify it. But it's important to notice here that it's the negative that makes it inverse, and the 2 goes down as part of the denominator as well. In the fifth law, we've got fractions. So or fractions as indices. So if we take 8 to the half, this is really the same as writing the square root of 8. We might do another example here as well. So we'll do 5 to the 2/3, because we want to see where the numbers of the fraction go. This is equivalent to the cubic root of 5 squared, or the cubic root of 25 if we were to start to simplify that. And last of all, we've got the rule that anything to the power of 0 is 1. So it doesn't matter if it's 100 to the power of 0, that's also 1. Might be worth pausing the video for a moment and writing these laws down to help you in this topic. Moving into question 1. So let's start applying some of these rules. When you're doing this, we're looking at law number 1 here. So we're multiplying all these, so we're going to be adding indices together. Just remember that any of these little indices here have actually, any of these letters have actually got little 1s. If you can't see something there, there's a 1 there. We don't bother writing it, but for the purposes of making this nice and clear, let's do that. So 9 times 7, 63. Let's take care of the numbers first. We might just make that pen a bit skinnier. So 63, and then I'll start working through my letters. So there's no particular order. Alphabetical could be good if you like. So we can go C first. There's only one C there. So we'll leave it as C to the 1. You don't need the 1, okay? So you can just write it as a C. I've got D to the 1 here, and I've got D to the 2, so I end up with D to the 3 once I've added those together, and I've got M to the 2 and M to the 1, so I end up with M to the 3, and that's finished. The second one, let's take care of the numbers first. So the numbers, we've got 4 and -2, so 4 times -2 is -8. Let's start collecting up our letters. I've got 1C here and 1C here, so I end up with C to the 2, and then I've got E to the 5 and E to the 4, so it'll become E to the 9. Just don't get tripped up. This negative sign here has got nothing to do with the indices, okay? Nothing to do with the little numbers at the top. It only affects the coefficients, which are the numbers here in front, okay? So there's a -2 and there's a 4. That's what the negative's for. Nothing to do with the indices. Okay, C, we got a -4 times 5. That gives us -20. I've got A to the 6 and A to the 2, so that'll make A to the 8. But B to the 3 and B to the 1, so that will make B to the 4. Question D, I've got 14 times 11, so I've got 154. And then I've got V to the 5 and V to the 2, which is going to make V to the 7. I've got A to the 2, so that'll just stay as A to the 2. And then I've got H to the 4, which will remain the same as well. E, I've got 4 times 6 times 6. So I've got 4 groups of 36. That'll be 144. Oops. And then I've got A to the 7, A to the 2, and A to the 4. So 7 plus 2 is 9. 9 plus 4 is 13. And I've got F over here. Oops. So I've got 4 times -1 times 4. So that will give me -16. And then I've got M to the 2, M to the 2, so M to the 4. And I've got V to the 2 and V to the 2, so that's V to the 4. And that's all collected nicely. Alright, in question 2, I'm simplifying, but this time I'm simplifying ones with brackets rather. So if I go over and have a quick look at my rules, remember that's rule number 3 there. So that little 3 that's sitting over here on the edge, it applies to everything in the brackets, and this is not something that we talked about earlier. So remember there's a little 1 over the top of the n, so we have to multiply them together. So n to the 1 becomes n to the 3, because we've got 1 times 3, and then we've got b to the 15, because we've got 5 times 3. In the second example, that 2 applies to everything in the brackets, so we've now got d to the 6 times 2, which is 12, v to the 2 times 2, which is 4, and p to the 4 times 2, which is 8. And in the final one, we're just going to make a point here that the 8 has also got an indice of 1. So this doesn't just apply to letters, it applies to the numbers as well. So we've got 8 squared, which is 64, and then we've got a to the 3 times 2, which is 6, and we've got c to the 2 times 2, which is 4. And I might actually just put an extra line of working in here just so that it's completely clear. So I'll move this one down. My first line could be 8 to the 2, a to the 6, c to the 4. And then what I've done to get that 64 is I've done the 8 squared. Alright. And now we're simplifying. These ones have got multiplications and they've got addition and subtraction in them. So there's a little bit of BOD math here. what we'll do is we'll solve the indices and then we'll collect any like terms that we might find. So we've got 8 times 3, which is 24. Then we've got a to the 7 plus 3, so to the 10. And then we're taking away 2 groups of a to the 4. Now, we can't do anything with that. We're only collecting like terms here, and a to the 10s are different to a to the 4s, so this is as far as we can simplify this. In question B, do the multiplication parts first. We've got 5 times 2, which is 10, and then we've got c to the 2 plus 2, which is 4. And then the second part of it, we've got 11 times 3, which is 33. And then we've got c to the 1. So 1 plus 3 is 4. Now, these are like terms. We've got 10 groups of c to the 4 and 33 groups of c to the 4. So we can simplify this one. So this will be 43 groups of c to the 4. And that's my final answer. Question C, again, we're going to have to do the multiplication first. So we've got minus 8 times 5, which is minus 40. And then I've got m to the 5 plus 1, so 6. I've got this little m sitting here, and I've got my minus 2 m to the 6's here. So we have got some like terms. These ones and these ones are like terms, but that little m in the middle is not. So let's collect what we can. Oops, I've got minus 40, minus 2, so I've got minus 42 groups of m to the 6, and a little m to the 1 there by itself. And D, let's do multiplication first. So we've got 9 times 1, which makes 9. P to the 4 plus 2 is 6. And then we've got 3p to the 7, and that's as far as we can go. Question 4 is division. So remember back to our index laws, when we're dividing, we subtract the indices. So they're both V's, so we've got V to the 12 minus 4, which is 8, and that's my answer. Next one, I've got D to the 5 divided by D to the 7, so I've got D to the 5 minus 7, which is minus 2. Now, something we have to be a little bit mindful of here is just go back and double check the question, writing with negative indices where possible, where necessary. So it's fine to leave question B as a minus 2, but in the next question, just skipping ahead, we need to write it with positive indices. So when we get to that, I'll show you how to do that. And then in this last one here, we need to be very careful with this question. And I've noticed that the answer sheet's actually wrong for this one. There's no brackets here, okay? This is a very different question to the questions below here, where it's everything divided, everything at the top divided by everything at the bottom. So this question is actually 11 times c to the 4 divided by 22 times c to the 15. So what that means is if we go through and we sort out the numbers first, so 11 divided by 22 is a half, that's fine. But then I've got c to the 4 multiplied by c to the 15, not divided. So we're adding those indices together. So this is times c to the 19. We add them together. This could be better written too. I'd write this as c to the 19 over 2. Now, the answer sheet, just to demonstrate what I'm talking about here, has got a different answer. So if I'd written this question differently, if this question was 11c to the 4 divided by 22c to the 15, and this part was in brackets, so in other words, it was this first section here, 11c to the 4, divided by the 22c to the 15, then what we would find is that we'd have a half, and then it would be c to the 4 minus 15, which would give us minus 11. Okay, so that's how we'd get that answer. But in this question, that is technically incorrect. Let's skip down to these ones, because these ones answer this a little more easily. So this one is division as well. So we're still following the rules of division. We're subtracting the indices. But what we can do here is we can work vertically. This is supposed to be a solid line all the way through here, by the way. So this says m to the 3, n to the 2 divided by n to the 1, m to the 6. So I'll put a little 1 in here so we don't get confused. And what we can do is we can just work vertically on this, and we can just eliminate things as we go. So if we have a look at this, we've got n to the 2 minus n to the 1. So at the top, we're left with, well, let's do the m's first. Actually, I'm just trying to confuse us really, aren't I? So I'm going to do the m's. I've got m to the 3 divided by m to the 6. So that becomes m to the minus 3, because 3 minus 6 makes minus 3. And then I've got n to the 2. If I go in a different color, I go n to the 2 divided by n to the 1. So I've got n to the 2 minus 1 makes 1. We don't really need the 1 there, but I'll keep it there just to show. Now, this question, if you remember correctly, was writing with positive indices. Now, if you go back over to your index laws, we named the number 4 was this one, where if you wrote it with a negative here, you could send it down to the bottom and it would become positive. Okay, so what we can do with this negative is we can send it down under the fraction line. So it can become n to the 1 over m to the positive 3. And now we've answered it with positive indices. Let's try the next one. We've got 6 divided by 1. That's not really going to change anything. Oh, sorry, 6 over 16, isn't it? So we can solve that fraction. So let's do the numbers first. So we've got 6 divided by 16. That's going to be 3 over minus 8. And now let's sort out the letters. We've got d to the 3 divided by d to the 2. So we've got d to the 3, d to the 3 minus 2, which is 1. And then I've got m to the 2 minus m to the, so m to the 2 divided by m to the 7 means that I've got m to the 2 minus 7, which makes minus 5. So let's tidy this up. Positive indices only relates to the indices, not this minus 8. That stays the same. The coefficient won't change, which is the number in front of the letters. The d can stay at the top, so that's d to the 1. The m can go down, so its indice becomes positive, and that's your final answer. And the last one looks like 9 will go into both of those numbers, so we'll end up with 3 on 2. We've got w to the 6 divided by w to the 3, so that's going to leave us with w to the 6 minus 3, which is 3. And you've got m to the 2 minus m to the 1. So m to the 2 divided by m to the 1, so 2 minus 1 makes 1. And that's our final answer. We don't have to rearrange anything to make them positive. Factorising. So factorising, we'll get what we can out in the front in brackets. So looking at these two terms, I've got m's in both. So I've got, little indices here. So I've got m to the 1. I can only take the smallest index number, the smallest indices. So I can take m to the power of 1 out the front, and I'd have c, and I'd have m to the 3 plus d. And just so that you understand what I'm doing here, if I do m times cm cubed, I'd get cm to the 4. And if I then did m times d, I'd end up with dm. let's try factorising the next one. Highest common factor of 6 and 24 is 6, so I'll take that out the front of the brackets. I've got v's in both of these, and a very non-mathematical way of me saying this, I'm going to take the smallest number of these, okay? So I'm going to take the v that's got the smallest indice, and then in brackets that leaves me with 1, and then I've got minus 4 v to the 2 left. That was it. Really didn't write very nicely that time with the pen. The touchscreen's really not loving this. There we go. So again, 6v to the 4 times 1 makes 6v to the 4. 6v to the 4 times minus 4v squared makes minus 24v to the 6. Excellent. Last one. 7 will go into both those numbers, so let's take that out the front. And then let's have a look. I haven't got any A's in this second term, so I can't take any A's out the front. But I've got M's in both. Remember, I'm going to take the one with the smallest indice number, okay? And then I'll write what I've got left. So 7 times 4 makes 28. I need an A, and I need an M to the power of 4 here. And then I'm going to go 3, and I've got that sorted now, so let's just double check. 7m to the 3 times 4am to the 4 does make 28am to the 7. Great. And then 7m to the 3 times minus 3 makes minus 21m to the 3. So we've got that one sorted. All right, last two questions, and what we're up to here is compound interest. So this is what happens if you borrow money or you invest money. So in this case, what they've done is they've put money into an investment, and they want to know if that amount of money is going to increase. So you've got A, which is your account balance. So we better write some of this stuff down because this is the first time that we've seen this formula. So in the formula, A is your account balance, the amount of money that's in your account. P is your principal amount. That's the amount of money that you put, principal. Okay, that's the amount of money at the beginning of a loan or at the beginning of an investment. So if I borrow $10,000 to buy a car, that's the principal amount, but I'll have to pay back more than that. Or if I invest $10,000 in something, then that's the amount that I first put up, but it will accrue interest after that. And then R is the rate. This one's tricky. You've got to be careful. It must be a decimal, okay? So you can see in the first question here that they've given it to you as a decimal, but in the second question, they've given it to you as a percentage, so you have to turn it into a decimal before you're allowed to use it. So we'll get to that in the second question. All right, and then N is the number of compounding units. So basically it's time, okay? So we've got 3 years, so we're going to have 3 compounding units. So let's give these some values. We don't know what A is, that's what we're trying to find, okay? The principal amount was 77,000, and a rate was 0.09, and we had a number of compounding units was 3. And now all we need to do is just put it into the formula. So we'll go A equals P times 1 plus the rate by N. So the amount will be 77,000 times 1 plus 0.09 to the power of 3, pop it straight into your calculator exactly as you see it, and the amount will be $99,717.23. And so you can see how interest works. Interest is the difference between this number and this number. Okay, so it's how much the amount has grown by. Let's do the second one. In the second one, we'll name up our things, our values as well. We'll have A, we'll have P, we'll have R, and we'll have N. A, we don't know. That's what we're finding. Our principal this time is a bit smaller, 1,460. Our rate, be careful, you have to convert it to 0.07. And then the time, or the number of compounding units, is 25, for 25 years. And now we just sub it into our formula and solve. So the A will be P times 1 plus R to the power of N, which means that A will be a principal of 1,460, 1 plus 0.07 to the power of 25. Pop it in your calculator exactly as you said, and the amount will grow to 7,924 and 5 cents. And that's the end.